Hey guys, welcome back. Alright, so I hadn't done a video in a while, or haven't uploaded any at least, but let me show you what we've been working on. So, we were at the shop and we're looking at the car and we're figuring out what's left to do and seeing if there's anything like difficult or stuff we gotta wait on. And really the hardest thing left is the electrical, and we've already got like 90 something percent of the parts. But here's what we didn't have. We didn't really have like our switch panel, our gauges, that type of stuff. We have gauges, we have switches, but we didn't really figure out like where are these things going to go, how are they going to be connected, that type of thing. So let me show you how we're going to do this. So when you're sitting in the driver's seat, since there's no passenger seat because it's a race car, this panel is going to be somewhere in access of the driver, probably like on the passenger side. That way you could like reach over, like twist your body a little bit, and all your switches and stuff would be right there. So let me show you basically what this is going to be. So in the top left here, you can see this section. We're going to have two different LCDs. The one on the left will be your battery voltage, and the one on the right will be your amps. Also, another thing to mention, this is kind of important. We are not going to do the 17 volt system right now. We tried really hard to get that to work, and it's too big of a project, and I decided we're gonna do a compromise. So instead of, and I didn't like this, but now I kind of warmed up to it. So we're gonna do a 16 volt battery. So I ordered a fifth lithium cell, and we'll put those in series, and so you'll have a nominal of like 16 or 17 volts. So that's what we're going to do. So anyway, this left one here, that's your voltage, and this one right here, that's your battery amps. Now, battery amps aren't like super common, but I've always wanted that, and I've appreciated that in like other like industrial equipment and stuff. Being able to see your amps is kind of nice. You can tell just being able to see volts and amps, but specifically amps. For example, anytime you turn something on, like anything, it pulls amps. So you can just be staring at your amp meter when you flip something on. That way, like, say you flip a switch and your fan was supposed to turn on, but it didn't turn on. Well, if it didn't turn on, it's not going to be pulling any amps. So it's like a dead giveaway something's wrong. And on a race car or a big old piece of industrial equipment, you may not hear a little pump or fan or rear tail light or whatever. You know what I mean? So like say if I flip my rear tail lights on and they normally pull 1 amp. Well, I can't see them without getting out of the car, but I could see the current draw on my meter. So it's a nice little it's a nice to have. Gauges, I'll be honest, I don't remember what these are. We're going to have some other panels we're going to go over in a minute. These are specifically stuff that you would look at before a race or maybe after a race, but not during a race. So that's why they're not in the field of view of the driver when you're like seated looking through the windshield. So this would be stuff like engine temperature, trans temps, oil temps, stuff that doesn't really change in the course of a few seconds, but you would want to know what it is. That's what these gauges will be. Uh, let's hit the big stuff. I'll come back to the little stuff. So you see this giant row going across here, right? So there's this huge row going across there, and there's another row right below it. Yeah, that probably shows up on video a lot better. So this top row, these are switches. So there's going to be a row of like a ton of switches. And these are all these like super heavy duty. I don't have a picture of it right now, but these switches are rated at 50 amps a piece. So we're actually skipping the relays and we're just running the power right through the switch, but it's all heavy duty, so it'll work. It kind of simplifies the wiring, adds a tiny bit of weight, but it's simpler, and I want to try it this way. I've liked this in other applications, so we're going to try it here and see if we like it here. Anyway, you'll note this one on the right's a little bigger. This is actually a push button for the starter, and it's actually a big old heavy duty push button. It's not actually turning the starter on, but it does turn the starter solenoid on. And I went and measured a Miata starter solenoid, and they actually pull like 40 amps, or at least mine does. Seems insane. So I got a switch that's actually rated at 50 amps, so we should be good on that. So anyway, top row is switches. Below that, these are lamps. So these are like little LEDs. I'll show you guys that eventually, but they look cool. And so that gives you, like, anytime you flip the switch, power should be coming out of the switch and the light should turn on. So like if you ever have a blown fuse, the fuses are before the switches. We'll get to that in a minute. That way, if you ever have a blown fuse, when you flip the switch, you won't see the light turn on. So it's kind of like a dead giveaway that something's wrong. You should always see the light turn on. Now, you will notice this one switch here actually has two lights. The reason is this switch is to turn on your automatic fan control. This is the cooling fan for the engine. So the first light, when you flip the switch, this just tells you that your auto fan control is enabled. And the second switch, as you can guess, is when the fan's actually running. that's when this one turns on. So that's a little bit of feedback for the driver. Now this did require a relay. We had to sneak a relay in for that, but I thought it was worth it. I really like the feedback of knowing that it's on versus knowing that it's running. Uh, anyway, these are lamps. If we drop down here below, these last three things, you see these sets of holes, like let's see if this will work. Yeah, like right here. Like this is a screw terminal. So this is like a terminal block. It allows you to run your wires to the block and then you can connect right to the block. So you can like stick a wire in or a spade terminal or a ring terminal. In our case, they'll be ring terminals because that's what I prefer for kind of like reliability and toughness. Because like if you use spade terminals, you push them on, well, you can just pull them and they come off. I've seen spade terminals vibrate loose. That's common, like just from vibration or wires tugging, they come unplugged. And the other big problem I've seen, spade terminals, they just rely on friction. So when you push them together, if you have like high current flowing, especially if the connection becomes dirty, corroded, whatever, they can start to heat up. It'll melt the contacts and relays. It'll cause voltage drops. It can cause a connection failure, smoldering, potentially a fire hazard. So I prefer ring terminals. Ring terminals, you have a physical screw or bolt and it runs through the ring terminal. And when you tighten it down, it's captured and the bolt obviously just pinches the crap out of it. So the friction problem's gone. You get a solid connection, and tugging on it, it won't come off because it's captured as a ring terminal. Always love those. We're exclusively using those everywhere we can. All right. So that kind of covers like the basics. What I didn't get to is the fused power. So that's this row up here. So these, I purchased them, and sorry I don't have pictures right now, but this is basically like a fuse panel where you run a big fat wire to it, and then it presents several fuse circuits. So there's like 8 here, 4 in the middle, and then another 8 over here. So it's like a total of 20 fuses. I think it's 20 switches, something like that. I don't remember. But it's a lot. We got spares as well. Let me show you one other thing real quick. So this is our diagram. It's roughly how things are going to be. So we'll be able to turn our gauges on and off, our warning panel on and off, injectors, ignition, VVT, wideband. That's the engine fan automatic mode, our water pump, our ECU, our trans brake armed or not. So there'll actually be buttons on the steering wheel to trigger it, right? But this is just to arm it. A couple of spares. We ended up adding some more spares. So we got like, I don't remember, but at least 4 or 5 of these. Here's our engine fan manual. So you can just manually turn the fan on for extra cooling, running lights, headlights, and that's our starter button, push button. So that's our switches. So a couple things worth noting. Up here in the top, you'll see these 2 holes. This is a solid state relay. So for the trans brake, to be able to like bump in, you can do like some cool stuff with a standalone where you can like PWM your trans brake solenoid and it'll allow you to bump in like really nice, but you need a solid state relay to do that. So these 2 holes, that's what those are for. And then this one hole over here, that's for a relay that I purchased. That's going to be used for the automatic fan control. And sorry I don't have pictures of it. I'll show you later. It's kind of boring, but it's just a big fat relay. It actually says China on it, which makes me feel bad. But to tell you the truth, I bought this from one of the most reputable, expensive wiring companies in the world, and it's rated for 80 amps continuous in automotive environment. So I think it's going to be fine. And it also has spade terminals, but they're 3/8 of an inch wide. They're on the switching side. They're humongous. So we should be good on that. Anyway, so that's this panel. This is going to be laser cut, probably out of aluminum, roughly 1/8 inch thick as you can see it. These holes on the very bottom, this is just to like bolt some tabs to bolt this to the car or something. I don't really have that 100% figured out. But as you can see, all these little holes, these are like tap drill size. So for example, up here, the fuse blocks, or down here, the screw terminals, or the solid state relay, or all this stuff, whatever these holes are, I looked up the tap drill size, and I'm going to buy the taps, and these are going to be laser cut to size, and all I got to do is run a tap through these holes to thread them, and at that point, all the holes are in the right spot. So when this panel gets here, all the parts just go together. You just run the bolts in, like really easy. So it should look pretty clean and professional, and it won't have a lot of bolt on one side, nut on the other. Always, nobody likes that. So for the most part, this will be fairly simple. Now, one thing, some of you may have picked up on this. I didn't mention it, but I've worked on this a lot. And one of the things I accomplished is if you look at this row here, this section is where power comes in. So this is your fuse panel and distribution. Once power comes out there, it goes through the switches. And then once it comes out of the switches, it crosses through the lamps so you can see if you got power, and then after that, it goes to the screw terminals. Now, what you probably noticed if you were paying attention is the flow of this. Nothing is crisscrossing. Power moves from the top to the bottom. So from a wiring perspective, all the wires will just kind of naturally flow down. And so that makes like running wiring a little bit more efficient. The wires will be shorter and they won't be crisscrossing everything all the time. So I tried to keep that in consideration. I ended up at first, like for example, I had the switches towards the top and the lamps above that, and then I had the screw terminals at the bottom, and then I wanted to put gauges, and I put them at the bottom and then at the top, and just this is like the this is actually, yeah, it's right here. It's the 17th revision to this panel. So that's a little embarrassing, but I'm actually pretty happy with the way it is now. I wouldn't regret building it just as you see it, and that's probably what we're going to do. Now, we're not going to build this. We're going to get it laser cut because that's faster and cheaper and all that kind of stuff. But, okay, that panel. This video is kind of run on, but I'm going to quickly run through another one for anybody that's interested. So what you see here, this is another panel. This one, okay, so this panel is going to go where your dash, like your gauge cluster would normally go. So this is going to be a warning panel. I could do a whole video about details of this, but essentially right here, this big giant one is right in your field of view. When you're looking straight ahead, this light would be directly below your line of sight. This is a big green lamp. This should always be on when you're ready to race. So this is a warning system. This requires a computer, software, sensors. I'll go into that later. But essentially, when you're driving, if you're ready to race, that light should be green. All this other stuff would be off. Now, each one of these up and down pairs go together. So like right here, this would be, it's at the top. This would be a row of red lights. Below that, you would have a row of yellow lights. So that way it's easier to see a warning from a caution. Now, these would be things like oil pressure, coolant pressure, fuel pressure, critical stuff like air-fuel ratio. I don't really remember all the things because I don't have the papers in front of me, but you get the idea. Whole bunch of systems, so you can, all the critical stuff that you would actually care about knowing when you're racing, you have warning stuff for it. So this gives you like peace of mind, and you can enjoy driving the car, and you're not like, oh, I wonder if this, oh, I wonder if that. It's like, nope, I got a green light. I know everything's good. All the critical stuff's being monitored. I've always wanted this in a car. Finally going to have it. I'll do a separate video about how I'm architecting all this stuff. But for this, there's the panel. This will get laser cut. We got some holes to bolt this in. Might adjust that a little bit, but actually it's probably fine. So that's that one. Okay, last one. This one's pretty simple. So y'all can probably guess what this is for. This is for gauges. Now the wideband we're running, it's called Behlinger Motorsports AFR 500 version 2. This guy's specifically set up with like a high accuracy sensor, and it's calibrated for methanol. So it's a little goofy. That's what this rectangle one's for. It's like a weird shape. It's got the controller and the display all built together. I wish it was a round gauge because it would be easier to install, but at least the display is kind of big, so that's nice. So it's going to go in that slot. These last three are things that you might actually want to look at when you're racing. So this is going to be like oil pressure, probably fuel pressure, and boost, something like that. I don't really remember. I only put three, so I don't remember what they were. But somewhere I came up with the three that I thought were important and put that there. Maybe I need a fourth one. Maybe we'll do that. But anyway, that's this panel. Again, getting laser cut. Looks like I forgot to put some mounting holes in it, so we'll do that before we order it. But I wanted to show you guys this. This is kind of like some work you do up front, but then when it's actually time to wire the car, having stuff like this already designed and built just makes everything go together easier. So we're going to finish up some mounting holes on this, maybe add a fourth gauge if we think we need it, and get this order placed because I need to get these panels. My company, I use SendCutSend to cut stuff for some stuff. And they've went up on prices, and they're slower to deliver, so that kind of sucks. I wish it was as good as it used to be. But nonetheless, we're going to get those orders placed, and hopefully in a couple weeks we'll have these panels. All right, guys, y'all look forward. I should have another couple videos coming out. We're going to do some about the architecture of this system, and it's kind of interesting. But I'll save that for the next one. All right, guys, till next time, y'all take it easy.